All right. Well, today's session is brought to you by OSSE and the Division of Teaching and Learning in partnership with DCPS. One of the ways that the Division of Teaching and Learning helps support teachers across the district is by providing research-based, high-quality professional development and support. In today's training, I will also be highlighting some high-leverage practices in a yellow box. They're going to pop up and appear. I think there's just one of them today. But this is basically just a research-based practice that's been demonstrated to impact student achievement and have a positive impact on all students. And so we like to elevate those and just, if you're not already doing them, encourage you to do so. And if you are doing them, pat yourself on the back. All right, great. Got some good thoughts coming in the chat box. Rain, hip hop music. Keep those coming. So my name is Tanaga Rogers, and I am the math content specialist at the Division of Teaching and Learning. Outside of this work, my passion for math, I am also a wife and a mom of two, a little girl that's 5 and a boy that is 7 years old. And I also enjoy traveling and dancing. And today presenting with me is Gabe Cartagena, and he's going to introduce himself now. Thank you.
Thanks for the introduction, Tanaga. My name is Gabe. I work with DC Public Schools. Excited to be here. I have a 3-year-old daughter, so my calming sound is whenever she's asleep, because that means I can do whatever I want and relax. So that's my calming sound.
We need an amen from all parents out there. All right. So on the screen are some norms that many groups find useful. Go ahead and take a moment to read through them. And if there's anything you'd like for us to add, you can share it in the chat box. So today's session is going to be very engaging. We've got some interactive opportunities for you to share with each other and discuss some mathematics. And so we're going to ask that you try and participate as much as possible today so that we can learn from each other and just grow and enjoy the conversation, the adult conversation about math. When you're not speaking, try and keep your mic on mute. And when we get into some breakout rooms, if you'd like to take turn your camera on, go ahead and do that as well so that you can see each other. Your daughter's nickname. On the screen now is our agenda for the hours on the left, and what we hope to accomplish is on the right. We're going to spend some time doing a math task to think about how productive struggle looks and sounds and feels like in our math classrooms. We're going to share some research and recommendations on how you can plan for productive struggle in your classroom. We'll share some classroom examples, and then at the very end, we'll take some time to be intentional and think about how it applies to the work that you do. Today's session is part of a larger series. There's one final session coming up on November 19th. Today's session is about planning for productive struggle, and last week's was about conditions for productive struggle. Eventually, those will get posted on the website, so if you did miss last week's session, it will be available soon. And at the very end of the series, we are going to be starting a book study in January on productive math struggle, a 6-point action plan for perseverance. So if you choose to, or if you're interested in participating in the book study, we'll share information at the very end. There's a free book involved and great discussion. So stay tuned for that. Before we dive into today's session, we want to take a moment and recap from session 1 about what productive struggle is and lay some of the groundwork for today's session around planning for it. So on the left is a graphic that illustrates the cognitive engagement as it relates to productive struggle. And then on the right, we've taken a quote from the book, Productive Struggle, a 6-point action plan for perseverance, for fostering perseverance. So take a moment, look at the image, read the quote to yourself, and then share in the chat anything that resonates with you from the image or from the quote, or maybe find something that connects between the two. Lots of good ideas coming in the chat, Gabe. Someone says the image reminds me of the zone of proximal development. Someone said, Virginia says about balance, right? This idea that if you lean too far to the left or to the right, then you are not in that careful balance or range of zone of proximal development. Jenna says both of them state that work should challenge students, though the quote does not include the necessity that the task should not be impossible for students. Couple more ideas. It reminds me of the challenge of finding the overlap for each student. The accessibility piece is challenging. Sometimes feels like it's never enough. I could relate to that, Jennifer. Marian sees some connections between task and engagement. I love that grappling with concepts is here. How do we not infuse state tests with watered down versions? Yes. Connections there. Keep those coming. I'm going to go ahead and let Gabe transition us to the next session. Go ahead, Gabe.
Thanks, Tanaga. So we're going to have some time to do a little math together, which I always think is exciting whenever we do math PD. But first, to kind of ground ourselves in the process, we're going to share a short instructional routine, which is going to be displayed here as a little staircase. Let's see. Am I able? There it is. So there's the little staircase. And so this is just going to capture a little bit about the routine that we're going to use. So first we'll have some individual think time or processing time. Then we'll shift into some group work where Tanaga will send us out to breakout groups. We'll have some time to come back and do some more individual think time or reflection time before we meet as a whole group. While this particular PD is not focused on this instructional routine or instructional routines in general, if you do want to learn more, this is a great resource. It's called Routines for Reasoning, and it is definitely a key component in thinking about how do we support productive struggle with our students. And we'll also get into this a little bit more next week. All right. So what is the task? Tanaga sent us an email last, what was it, Tuesday night? About the painted cube task. If you haven't had a chance to read it, no problem. So we're going to revisit it here as a group. But imagine you have a Rubik's Cube, which is made up of 27 smaller cubes. I think the screen just went away. But I'll do this from memory. So imagine you have a Rubik's Cube. It's built of 27 smaller cubes, and you're going to dip it in some paint. And so the idea is we want to figure out how many of the cubes have yellow paint on their faces. And if you want to take it a step further, how many of those faces are actually painted yellow? And so Tanaga is going to show us a short video clip of what this looks like, and then we'll have some time to do some individual think time and then some group think. So we have the Rubik's Cube. It is getting dipped into a bucket of paint. How many cubes are painted, and how many sides of those cubes are painted? So let's take 2 minutes to think about this problem individually, and then Tanaga will send us out to our small groups. So it is 4:16. We'll come back at about 4:18. So that was about 2 minutes. I will note that we're doing a very expedited version of this instructional routine. If you were doing this with students, you would give more time. But let's take some time to go into our small groups for about 4 minutes to discuss some of the strategies we might have come up with. Are we still in breakout rooms, or did I just get booted? I can't hear you, Tanaga.
Oh, okay, I moved you out.
Oh,
I didn't mean to put you in a group, but I hadn't like named you a co-host, so it put you in a group automatically. I took you out because I didn't know if that would make people feel uncomfortable, right? Like they don't
oh,
need you watching.
yep, got it. Well, they're probably
Did
like,
they
where
get
you
started though when you
going?
were there?
Yeah, I started just kind of probing them and asking how they were doing or what they were doing.
Okay,
No worries.
Benedicta, can you click on your breakout session so you can chat with your group? Maybe I'm muted. So we'll give them a couple more minutes. I broadcast a message to tell them to share things that they might talk about. Did you, when you got to the breakout, did the message come up?
Yeah, the message came up. I'm not sure if people read it. I mean, we were having some good conversations just around different strategies. So, as Martin
Okay.
said, she kind of thought about the Rubik's Cube and started thinking about like how many squares might be painted, three faces, two faces, one face. Ms. Jacobs then shared how she thought about it in two-dimensional space, so thinking about like six
Ooh.
squares, and then
Mm-hmm.
also doing the same kind of like how many of them are painted three, two, one. Um, so yeah, I think we were getting into some good conversations,
Okay,
good
cool.
strategies.
It's
Yep.
about 3 minutes. So I will when I end the sessions, they'll have a minute to
To
wrap their
return.
conversation up. Yeah, it gives them like a countdown before it automatically boots them back here. So
Got it.
hi, Etienne. Everybody is in breakout groups right now. So they're going to come back in just a moment. They're chatting about the painted cube problem. So I think you got the file in the email. So if you want to just take a peek at it and then dive into the conversation when everyone comes back. All right, I'm ending breakout sessions.
Okay. I'll wait for the timer to go off before we restart.
And then next up is the poll. So let me grab that, get that ready.
Everybody should be here in about 3 seconds. Welcome back, everyone. Again, want to reiterate that this is a very expedited version of the timeline that you might use to do this activity with your students. So fully want to name that, but want to give you an idea of what this kind of feels like from the perspective of the student. So in your groups, you had an opportunity to talk through what are some possible solution strategies you might use or some tools you might have use in order to solve this task, as well as some questions. So Tanaga is going to share with us a poll to get a sense of what are some of the things that you all talked about. If you haven't answered the poll, let's go ahead and do so, and we can reflect a little bit more about what those results are sharing.
Yep, we got 20 seconds. Ignore if there's a timer that says 4 minutes, it's not really true. It's only 15 seconds left right now. And then I'm going to close the poll. Looks like just everybody's answered except for a few of us. So countdown begins now. We still have a few moments to participate. All right.
Drum roll,
Results, Gabe?
please. Yes. Um, so it seems like 14 out of the participants, or 14 people, suggested that it definitely or probably would lead to productive struggle, while 6 people said possibly or probably not. So we'd love to hear a little bit from everyone that had a chance to share. What are some components of this task that might have lend itself to struggle, and justify a little bit of your thinking behind that? And you can come off mute.
I think students having prior knowledge. I think depending on what grade level, it might not be prior knowledge of some things, so it would make it, a little bit of a struggle for them.
Okay, so that it could, thank you, Miss Hours. So it could lead to struggle if students don't have some sort of prior knowledge involved. Okay, Mr. Werner, are you raising your hand? I think you're on mute.
Hello.
Yep, we can hear you now.
We can hear
Oh,
you now.
yeah. So,
Go for it.
I just wanted to say that it allows students to it doesn't give them a way to solve the problem. So it allows them to develop their own strategy and create their own way of going about the problem, which I think is going towards productive struggle.
Yeah, so this kind of open-endedness to the task or multiple solution pathways makes itself or lends itself to productive struggle.
I wanted to can y'all hear me?
Yep, we can hear you.
Okay. I wanted to share that on the outset, it seems like it's straightforward, but when you realize that, oh, there's a little bit more to this than you think, then you're like, okay, well, I think I can access this, because at first I thought I had it, but now this is going to take a little bit more time. So I think that's why we can say that there will be a productive struggle.
Okay, so what I heard you say is two things. One is that there is access, or there's an entry point for all students, but then the actual demand of the task itself requires some more thinking involved.
Yep.
Awesome, thank you for sharing that. Let's hear from maybe one more person.
Yeah, and I think that thinking that was just mentioned is forcing students to think about how they're going to conceptualize the problem, to see it, to be able to organize the information that's presented, separating out what's needed and not needed. So they're gonna have to struggle through that in order to come to a definitive answer. So I think that struggle in that of how they're going to make a decision based off all that's going on.
Sure, thank you for sharing that, Mr. Ford. So there's some demand from students to think through what is the appropriate strategy that I might use in this case, as opposed to being told the strategy or the strategy be implied simply by the structure of the question itself. Thank you all for sharing that. We are going to get into a lot more strategies when we think about how do you support students in a task like this. But I did want to bring up, because I saw some comments earlier from our opener when we talked about what is productive struggle and entry points, accessibility, and there's sometimes being this tension between accessibility and challenging. If you were to do this in in-person learning, you could provide students with sugar cubes and things that they could actually paint and color and manipulatives and that sorts of thing, which can definitely increase the level of accessibility. Similarly, you can do something called a referral, which we'll preview next week, but giving students structures like charts and tables that can help them also process the information that they're receiving. And so even within a task like this, there are additional supports and scaffolds that you can add if you are concerned about the accessibility for your students or for some of your students. So there are always options and opportunities to make modifications to tasks, but generally speaking, this was a very open-ended task that made itself accessible for students. With that, I'm going to toss it to Naga.
Thanks. I'm going to make a shameless plug there again for virtual manipulatives. This would be a nice task to have some cubes that students can manipulate on screen. And I'll share a tool that could be used for this task in particular in the Wakelet at the end. But now that we have an understanding of what productive struggle might look and feel like in the classroom, we want to spend some time now talking about how you can plan for math tasks that might offer students opportunities for productive struggle. And when you take the time to think about planning for a productive struggle in particular, you are actually doing a high leverage practice, which is adapting and prioritizing instruction to ensure that all students get a critical and robust mathematical experience, right? If students are going to meet rigorous mathematics goals, we have to plan for it and be intentional about that so that every student has the opportunity. So we want to dive into some features of high quality task. And before we do, we want to give a disclaimer out there that the features we're going to share today are not like an end all be all list. The presence or the lack of those features are there to help guide and help you decide if you should use a task or even how you might use a task, right? Because tasks have different purposes, right? And there's a time and a place for everything. So if a task doesn't check all the boxes that we talk about today, that doesn't necessarily mean it's disqualified. Even so, thinking about this list, we're likely to find a pattern of tasks that either check most of the boxes, and that would be the green light to go, or something that doesn't check any of the boxes, right? In which case we might think about a different way to use that task. So just keep that in mind that the list here is not all inclusive. So the first one we'll start with is alignment. And this is probably one that you'll always want to start with because it's basically just, is the task aligned with the learning goals that your course or your school or your lesson goal objectives are, right? So thinking about and making sure that the task is going to help students get to where you want them to be. And the next one, I think someone mentioned this in the discussion before, Gabe, which is multiple entry points, right? Making sure that students can approach the task in many different ways and that it's inclusive. And when we talk about inclusive here, we're thinking about creating a question that's open enough and allows for students at many different stages of math development to benefit and grow from the task. So making sure that the task isn't too narrow. And I think someone earlier used that phrase zone of proximal development. So thinking about, does this task meet the zone of proximal development for mostly everyone in the class, if not all of the students in the class? And some of the ways you might do that is with open or parallel questions. I think you had a resource earlier, Gabe, that you were talking about. Maybe it'll come to me later. Or you want to share it real quick?
I was going to share it later, but open.
Okay,
I was going to share it
really.
later. It's cool.
I'll tag you later then. Okay. All right. So the next one is communication. So thinking about when you're choosing a task, will this allow an opportunity for students to communicate about the mathematics? And just throw in the chat for me real quick. Why do you think communication might be important when thinking about a task and choosing, wanting your students to experience productive struggle? So why might communication be an important feature if you want students to experience productive struggle? Someone says, Etienne says, learn by teaching. Jenna says, talking helps students process the problem or the mathematics. Sharon shares that same line of thinking there with helping students to understand their thinking process. Yep. Mary says, if students are communicating about the problem, then it lets you, the teacher, know how the students are doing with processing and making sense of the mathematics. Students can fill the gaps of understanding from one another. It increases accessibility. That's right. How many of you tried to say something to students before and they never got it when you said it, but then another student across the room said it in other terms or other language, and it was like all the light bulbs went off, right? So sometimes just hearing it from someone else also. It's also, oh, I'm so glad someone brought that up. Yes, this is a key moment for English language learner students, right? Being able to write and communicate in math supports students' use of vocabulary and discourse. That's right. And this is one of the practice standards. All right. Yes. Attending to and working to accuracy, all of that is embedded in there with communication. So making sure that students have an opportunity for all of that when you're selecting a task as well. The next one is connections. Asking yourself and evaluating whether or not the task has opportunities for students to connect to concepts or connect concepts and procedures, or even connect to student interest. We talked about this in session 1 when we talked about enabling conditions for productive struggle and making sure that you as the teacher understand what your students' interests are and how the mathematics you're teaching applies to the life that they're living. And so this is another excellent opportunity to tie in some of those things that you learned about your students' interest into the math task, right? Making sure that the task connects to their interest and the math that they're using in their world. This helps with understanding, remembering the mathematics, right? If it's meaningful to them, all of that helps build their schema. And then the final one is solution pathways. So this allows space for students to develop their own strategies. I think someone mentioned this when we started the discussion as well, making sure that students have a chance to explore other student strategies, consider which strategy is more efficient. All of that also contributes to that math conversation as well. So another important thing that we want to consider when planning is making sure that you have tasks that speak to each of the elements of rigor. Pop quiz, what are the elements of rigor in mathematics? Throw those out for me in the chat. Although I guess it's not really a pop quiz if the answers are on the screen, right? But in other words, we want to make sure that your instruction in your unit of study includes equal emphasis on conceptual understanding, procedural fluency, and opportunities for students to apply that math and skills and concepts. So we want to first think about tasks that help build students' conceptual understanding, usually like when they're acquiring new ideas. We want to be sure that we're choosing tasks that do not just have students retell what's happening, and instead lean into tasks that challenge them to look for patterns and make generalizations and make sense of the mathematics on a broader scale. So take a moment and think about the course you teach and what might be some conceptual tasks, maybe that you've given in the past, or some big ideas or concepts in the course that you teach, where you might want to be looking for conceptual tasks that build on those concepts. Where are there opportunities for sense making and exploring patterns and relationships in the course you teach?
Not to sound stupid, but can you re-ask the question, because I just need a little more clarity.
Sure. What are the big ideas or concepts that you might teach in your course, whatever course of mathematics you're teaching? So a couple of the ideas, Teresa says, thanks for being brave and asking that, Carlita. So Evgenia says, figuring out a formula for arithmetic or geometric sequence. Okay. Proportional relationships. So I want to dive a little deeper, if someone can add on to that. What might be some big ideas about proportional relationships that you would want students to understand? Other ideas in the chat are like number sense. So what about numbers? What's a big idea about integers in the number line? Go for it. Be brave,
simple as even and odd. My sixth graders really struggled with that, because it was like, what do you mean? What do you mean even? And so just breaking out just the very concrete of, you can break them into even groups, that conceptually was mind blowing for them. I was like, y'all in sixth grade, how do y'all not? And then I realized no one had taken it back to the conceptual part. They knew the procedure. They didn't know the concept behind it.
And what's the procedure, Carlita? What's the procedure that most of your sixth graders knew? Even numbers are what?
Skip count, like 2, 4, 6, 8. If it ends in 2, 4, 6, 8 or 0, it's even. If it ends in 1, 3, 5, 7, 9, it's odd. They didn't think about they could be put into groups. And I spent a whole day and a half on that. I was like, but it actually deepened their understanding of ratios part to whole. So it was worth the day and a half I spent on it.
And Jenna's adding on to that. She's saying proportional reasoning, in particular, how rates and unit rates are utilized in comparing to rates as a collection of equivalent ratios and the future connection with slope and rates of change. Yep. So any activities where students can make those connections between concepts, those are conceptual type tasks, right? Let's dive into the next one. Procedural tasks. So I'm going to just add on to Carlita's idea with even and odd. So the conceptual idea there is that you can make two equal groups if the number is even, right? The procedural idea there, that students would need a task there to practice identifying whether numbers are even or odd. So when we think about procedural tasks, you want to make sure that students have an opportunity, not only for conceptual tasks, but also an opportunity to practice applying procedures or steps to complete a calculation. The focus here is not on giving students a lot of problems to do and doing rote practice, right? That is part of procedural fluency. However, we really want to dig deep if we're thinking productive struggle and focus on efficiency and varying maybe types of activities where students are getting in that practice. So maybe there's centers and games, or maybe a software application that they can practice with. It does not have to be just a worksheet with 10 problems, 20 problems on it. And Gabe's going to dive a little deeper into that one in the next section. And then the last one there is application. So thinking about, I'm going to build on Carlita's idea there again with even and odd. How do we apply even and odd in the real world? Where is there some real life application for even and odd? Or if somebody was talking about ratios before, how does slope show up in the real world? So a lot of times we think of application as just the word problems at the end of the textbook or the end of the chapter, right? But we want to dig deeper when we're thinking about productive struggle, and we want to think about ways that students might represent the problem and determine if their solution is reasonable and why. So causing them to dig deeper than just reading the word problem and solving it. Questions? Keep those in the chat. Keep them coming in the chat if you've got a question, and we're going to go ahead and transition. Gabe's going to give us some classroom examples to show you what some of those features and elements look like. Go for it, Gabe.
All right, thanks, Tanaga. And so we're actually going to zoom in here a little bit on procedural tasks, because generally when we have conceptual tasks or application tasks within our curriculum, they do a good job of helping to support productive struggle. But we're going to look at ways that we can take a procedural task and open it up for some more of that struggle or some more of those elements of struggle that we've been describing today. And so generally when we think about procedural tasks, they kind of look like this. It looks like an endless list of problems, right? It looks like this root memorization or this root practice with problems. So we're going to do questions 1 through 50, the odds in class, the evens for homework, and it's going to be a bunch of adding and subtracting integers, right? And what this tends to lead to is fatigue or perhaps disinterest from students because they're doing the same thing over and over again. For students that understand the concept, this is really boring, right? Because it's like, how many of these do you really need me to do? I know how to do this. And for students that don't understand the concept, this ends up being really overwhelming because they're not able to access it, or they don't even know where to start. And so some potential modifications you could do in these cases, because there are some standards that do call for procedural understanding, is you can do games, you can do centers, you can take a procedural task and allow for students to provide more than one answer, or also allow creating multiple representations. So on the picture on the right, we have an example of what this looks like with that example that we talked about with adding and subtracting integers. And so this looks very typical of some practice. Maybe you might give some students, let's add, or let's do subtraction. Let's take -2 and subtract -5. But instead of asking students just to identify the answers to these questions, we can ask them more poignant questions, which is, how are the add-ins related in the equations in each row? Getting them to recognize this pattern of, you have subtracting a negative, maybe that actually means you're adding a positive, right? How are the solutions to the equations related in each row? And how might you create new equations to show that this relationship is always true? So having them apply it in a deeper context and really assessing whether they are able to pick up on this pattern, right? And make sense of the pattern. Another example, very typical high school example, right? Adding and subtracting polynomials, super important concept. We definitely want to teach it. We definitely want students to understand like terms. But how do we take something on the left, which is, again, a bunch of practice problems where students are adding and subtracting, and maybe give them an opportunity for it to be a little more open-ended, for them to have multiple answers or multiple solutions to this. And it looks something like the following on the right. So instead of asking them to do the addition, let's have them create two polynomials whose sum is 5x squared plus 3x minus 4. You see how this creates a new space and a new opportunity for students to engage with the same type of reasoning and the same type of skills, but using a different area of the brain. Another example is create, after they do the first two, create two more. How are they creating this, right? What skills do they need to know? Do they need to know and be involved with? Well, they need to know that the coefficients for the x squared term needs to give me 5, but there's multiple ways to do that, right? You could do 2 and 3, you could do 1 and 4, you could do 7 and -2. So there's multiple opportunities for students to do that, and based on their level of accessibility or their level of fluency with the mathematics, they might choose easier or more difficult routes, right? And so this is an idea of how you can modify what is a seemingly procedural task, right? And make it a little more challenging and open it up for more productive struggle.
Gabe, I'm going to skip the opportunity to try because I'm looking at the clock and I want to make sure that we have time to reflect. So I don't ever like to rush that part. Is that okay?
I'm going to drop a link in the chat because we promised it earlier. This is an open middle problem that kind of gives the similar example around the polynomials of how you might be able to present it to students and even do it in the digital space.
Thanks, Gabe. So as we near the end of our session, we really like to be intentional about setting time aside to kind of process the information that we've talked about and think about how it applies to what you do on a daily basis. So we're going to take a few moments now to do that. So there's 2 questions on the screen. We want you to choose just one of them and just take a moment to think about it first, and then we're going to share our answers in the Padlet, and I'll drop the link in the chat box. The first one is, what do I consider when selecting a math task? So what are you currently doing when you're choosing a math task for your students? And then thinking about the features from today, which feature is most difficult for you to consider and why? All right, I've put the Padlet link in the chat box, and we're asking that you share your thoughts and ideas so that others can go back and read through them and glean and get ideas from each other. Both questions are there for session 2, and then the questions from session 1 as well if you'd like to go back at a later time and look at those. But for now, try and focus on session 2 questions. We'll give you about 3 minutes to do so. Looks like a lot of people select alignment, and with the current standards, thinking about that, that's awesome. That's really important. Give you about 30 more seconds to add your ideas. Some of the ideas that are more difficult are communication. I'm sure that too in this online environment, right? Connections. I agree with this one. Don't forget that you can use the button to agree with other ideas on the Padlet as well. But the one that really resonates with me, Gabe, is this one about coming from a high school background where more procedures are taught, being a pure math major where application was not necessarily a part of our learning. I think that one is one a lot of people can resonate with, a lot of math teachers, right? We weren't necessarily taught to know how the math connects. Gabe, I'm going to unmute you because you need to talk about that book. So go for it. Hold it up again. Everybody can check out Gabe. I'm going to.
Yeah, shameless plug. So this is a new book that was released. It's called High School Math Lessons to Explore, Understand, and Respond to Social Injustice. And so this has a lot of activities that you can use to inspire interest in mathematics that are socially relevant and allow for application of the mathematics to think about through with your students. And then another one that I just happen to have here too, as being my mouse pad. This one is for middle grades, but this is Mindset Mathematics by Joe Bowler and company. And this also has a lot of good math tasks that you can use that will really foster a culture of productive struggle in your classroom. So Joe Bowler describes it as low floor, high ceiling task. And it's organized by kind of big idea or concept. And she has it for grades 6, 7, and 8.
Coming soon to you from OSSE. And that's coming soon. I bought that book too. So stay tuned. All right. Well, we are
library books.
We are nearing the end of our time today. So I want to just close us out with some plugs for upcoming opportunities. So if you were really intrigued by some of the things talked about today and want to dive deeper and try some of these things with colleagues and then come back and talk about it, we are going to be hosting a book study on that book pictured there, Productive Struggle, a 6-point action plan for fostering perseverance. The link to register for the book study will come in a follow-up email from me. You got to register before November 30th, and I think we're already halfway full. So if you're interested, sign up. You get a free book, and we will discuss online in January and February. And to receive professional learning units for today, you will get an email that includes a link to a survey. You want to go ahead and complete the survey by clicking on Add Response, and you'll get an automated certificate that has your name and proof that you attended today's session. If you have the book, could you gift it to someone? Sure, I guess so. That could just be an empty slot. Yeah, why don't you just sign up for the book study and let me know that you already have the book, and then I'll leave the spot open for someone else. Jennifer, the link for the book study will come in my follow-up email. Gabe and I will be hosting that again together in January. So we hope that you'll join us if you enjoyed today's conversation. And as always, I'm available for technical support if you need help or support implementing this in your classroom, or if you're a coach and would like to take this back to your school, I'm here to partner with you. So just send me an email and I'd be happy to work together with you. Today's resources are all available on the Wakelet. So I'll put a link to the book that Gabe was talking about, the one that he shared. And then also we have some links to some virtual manipulatives on the Wakelet as well. Let me pull that up so you can see what's on there, as well as the resources from last week's session. So So on the Wakelet here, we've got templates for virtual manipulative tools. If you're looking for virtual manipulatives, we've got resources there. And then we also have some student-facing tools that you can share with your students. And then we've also got the slides from session 1, the slides from session 2 will be up there by the end of today, and lots of good stuff for you to dive deeper into. So thanks so much for joining us today. Gabe and I will hang around if you have questions. We'll be here for a couple more minutes, and we appreciate you showing up and doing some math with us and thinking hard about your practice.
Thanks so much, everyone. It was great seeing you.
Thank you. Bye-bye.
Thank you,
Oh,
guys. Have a
yes.
good
Let me
night.
put the link in the chat. There's the Wakelet, and I also sent it in the email as well, so it's there for you, and you'll get it in the email. The link to the survey will come in the follow-up email. And we hope to see you next week. The last session. Don't forget to